Hello, I'm Artemis Tusau. Today, my group members and I will be going to talk about superheater under the subject Energy Conversion MDB 4133. These are my group members, and my lecturer is Dr. Hussein Al-Kayiem.
Hello, I'm Darshan Ram will be explaining about the first part, which is the introduction to superheater. Superheater is one of the components in the boiler that serves to further heat the steam to produce steam that meets the requirement for turning turbines. The superheater is a collection of boiler pipes located in the flow of hot gases from combustion. The heat from this gas is transferred to saturated steam in superheater pipe, so it turns into superheated steam. And the next topic that I'll be talking about will be the working principle of superheater. Generally, superheater consists of two main parts, which are the primary superheater and secondary superheater. Primary superheater is the first heater that is passed by the steam after the steam comes out of the steam drum. After the steam is heated on the super primary heater, heating steam will be passed on the secondary superheater to be heated again. So, on the secondary superheater, steam formed is the hottest steam among the others. As you can see on the right hand side, it shows the process flow of the working principle of superheater. It starts from the steam drum, moving on to the primary superheater and then secondary superheater, and lastly it will reach the high pressure turbine as a superheated steam. And the next topic that I'll be talking about will be the components of superheater. There are four main components involved in making superheater, which are the combustion chamber, burner, steam coil, and measurement instrument. Combustion chamber is a space used for the fuel combustor process to heat steam. Second, the burner is to burn fuel in combustion chamber. It creates heat that heats the steam. Third is the steam coil, which is known as the steam pipe in the form of a circular squirrel. And last but not the least, measurement instrument is one of the most crucial components in superheater. It is because it allows us to find out the process parameters such as the temperature and the pressure, which can be the temperature of steam, whether it is in the desired state or not, and also the pressure, whether it is also in desired state or not. And the last topic that I'll be talking about will be the benefit of superheater. Generally, superheater serve a lot of purpose in power plant. One of them is to increase the efficiency of power plants. Second, it minimizes the erosion of turbine blade. This is because the steam is made sure to be in superheated steam before it reaches the turbine blade, which reduces the erosion of the turbine blade. Thirdly, is superheated lead to a less steam consumption. And next will be the reduction of condensation loss in boiler steam pipe. And lastly, superheated allow the temperature to be increased in the saturated steam. And that's all from my part. Thank you.
There are two types of superheaters. One, radiant superheater, and the second one is convective superheater. Radiant superheater, as you can see from the diagram, is installed in the radiation zone just after the furnace, facing the flame and direct radiation from the furnace. It's usually in high pressure boilers when temperature difference in the saturated and superheated steam is 100 degrees Celsius. However, for convective superheaters, they're installed after the convective bank of tubes, as you can see from the diagram, and shielded away from the furnace and the flame. When the temperature difference between saturated and superheated steam is less than 50 degrees Celsius. Let's move on to the design parameters of superheater. There are three main design parameters of superheaters, and those are boiler pressure, steam pressure, and temperature requirement in the process. That is all from me. Thank you.
Hi, my name is Vignesh and I will be talking about the uses of superheater. As we all can see, the first usage of superheater is the low quality steam can be transformed or can be also be converted to high quality steam. So what does a high quality steam means? High quality steam is actually a dry steam. Superheaters are used where only dry steam is required in a process or machine. A machine which uses superheater are commonly known as turbines because any moisture content in a steam will actually degrade or corrode the machine, which can later on affect the operating life of the turbine. Therefore, superheater in this scenario will actually maintain the steam only at dry steam and will prevent any moisture content to be entering into the steam. Secondly, superheater is usually applied when steam is needed to transport to far off places. Because when the steam transport itself to a far off places, it actually has certain losses during the transportation, which is temperature. Temperature usually loses during its transportation. Therefore, superheater usually try to maintain or increase the thermal energy, and most likely it will also decrease the condensation inside the steam. As we move forward, superheater usually prevents the wear and tear of engine parts because it will try to prevent a moisture content in the steam. As we mentioned in the first point, when there is moisture content in the steam, the average operating life of a turbine will actually decrease. When it decreases, that also means that wear and tear of engine parts has been used excessively or intensely. That is the only reason why the operating life decreases. Therefore, in another word, superheater is actually encouraging the longer usage of a turbine. Finally, superheater is also used in gas turbines because in gas turbines, hot gases will actually provide the required temperature to produce superheated steam, and superheater may be an additional part of the furnace area. It means when there are superheated steam in gas turbine, superheater once again maintains the temperature and try to reduce the loss of temperature during transportation. This actually increases the efficiency of a certain process or machine. To conclude this slide, superheater actually acts as a great tool to increase the thermal energy and thermal efficiency of a steam and its turbine. Thank you. Moving on to the manufacturing, all the superheaters should and must be manufactured according to the Indian Boiler Regulations, which shortly known as IBR. IBR is actually the regulations which cover material and equipment which used to make superheaters in India. Domestic and overseas manufacturers and suppliers of most superheaters and associated components built for India. The IBR was created in 1950 to enforce certain regulations which needs to comply to the Indian Boilers Act of 1923. It includes the boilers, which includes the feed piping from the discharge side of the feed pump, and steam piping up to including the stop valve of the steam consumer and attached fittings or vessels. It also has steam receivers, separators, steam traps, accumulators, heat exchangers, converters, and evaporators, and many more. Second point, Thermodyne is actually the world's largest manufacturer of rugged customized shipping cases. It has become an industry leader by providing exceptional protection, especially during manufacturing of the coil type and shell type superheaters. There are two types of superheaters, which is the coil type and shell type. Coil type generally consists of 180 degrees of coils welded through the headers on both sides. It has the coil type which design steam which is inside the coil, and the gases would be outside of the coil. Coil type superheaters are usually efficiently high, and it has a very low running cost. Therefore, manufacturers or buyers actually prefer coil type superheaters because it's easy to be installed and also cheap. Secondary, which is the shell type superheaters, which is designed generally to superheat the steam electrically using some special heating elements stacked in a shell, and the steam flows over the heating elements. This shell type superheaters has instant steaming within 5 minutes of a cold start. That means when you start it, within 5 minutes the steam is heated. So these two type of superheaters are one of the most efficient superheaters. These two images projects the coil type and shell type superheaters respectively prior to being discussed in the previous slide. With that, we have come to the end of our presentation. Hope this presentation serve as a guidance to everyone who would like to know more about superheaters. With that, thank you so much, Dr. Hussein, for giving us the opportunity to explain regarding superheaters. Thank you.